Transformers. Here we have a transformer which consists of an iron core, around which are wrapped a primary coil of insulated wire and a secondary coil of insulated wire. We apply power to the primary coil and take power off the secondary coil. If we apply an input potential difference to the primary coil, it produces a current in the coil. This current produces a magnetic field in the iron core. The iron core strengthens and directs the magnetic field. The changing magnetic field through the output coil induces a potential difference in this, which then produces a current. There's only an output potential difference while the magnetic field is changing, but if we use an alternating input potential difference, this produces an alternating current, so the magnetic field is constantly changing, and we get an alternating output potential difference. Here we have an AC input giving an AC output. Transformers only work with alternating current. In this case, the secondary coil has more turns than the primary coil. This means the output potential difference will be greater than the input potential difference. We call this a step-up transformer. The number of turns goes up, the potential difference goes up as we go from input to output. The potential difference changes in the same proportion as the number of turns. So we get this formula: the potential difference across the primary coil divided by the potential difference across the secondary coil will equal the number of turns on the primary coil divided by the number of turns on the secondary coil. In symbols we can write Vp over Vs is equal to Np over Ns. You can invert both sides to give Vs over Vp equals Ns over Np. You'd be given 3 of these values and expected to calculate the 4th. Though if one of the values of potential difference is the mains, you may be expected to know that this is 230 volts. This is known as the transformer rule. When the number of turns on the secondary coil is greater than the number on the primary coil, the potential difference across the secondary coil is greater than that across the primary. If the number of turns doubles going from primary to secondary, the potential difference will double, and so on. This is called a step-up transformer if the number of turns increases and the potential difference increases. A step-down transformer has fewer turns on the secondary than the primary. This will reduce the potential difference. Transformers are close to being 100% efficient. If a transformer was 100% efficient, the power out would equal the power in. Power is given by current times potential difference. So this would mean that the current across the primary multiplied by the voltage across the primary would equal the current of the secondary times the potential difference of the secondary. This means that if the potential difference increases, the current must reduce in the same proportion. A doubling of potential difference halves the current. Therefore, a step-up transformer reduces current. A step-down transformer increases current. The efficiency of a transformer, as with anything, is given by power out divided by power in multiplied by 100%. So efficiency is current secondary potential difference secondary over current primary times potential difference primary times 100 as a percentage. Let's just work through an example. A mobile phone charger converts the mains at 230 volts to 9 volts. If the primary coil has 2000 turns, we're asked to calculate the number of turns on the secondary coil. Well, using our initial equation, we're after the number of turns on the secondary coil, which is given by this expression. Putting in the values, we have 2000 turns on the primary, with a potential difference on the secondary of 9 volts. The potential difference of the primary, 230 volts. This gives 78 turns, which is close to 80 turns. If the phone takes a current of 25 milliamps, calculate the current entering the charger, assuming it is 100% efficient. Well, we know that the current primary times potential difference primary equals current secondary times potential difference secondary. We want the current in the primary given by this expression. We've got all the other values, and this gives 9.8 times 10 to the minus 4 amps. This is around 1 milliamp. Transformers have a laminated core to reduce heating within the core, so improving efficiency. They also have low resistance wires to reduce energy losses, meaning real transformers can be over 97% efficient. Some transformers, such as for mobile phones, work in a different way. They use electronic circuits operating at high frequencies of between 50 and 200 kHz. They're called switch mode transformers. They're smaller and lighter than conventional transformers, as they have no iron core. They also take little or no power when nothing is connected to the output, unlike conventional transformers.